Good evening. In the last videos, I think we covered only one problem, that is nothing but grid base. With that, we completed recursion and the applications which are working based on the recursion. We completed very clearly in the last session. Now, in today's
Sir, I have a doubt.
videos, yes,
Sir, in that permutation, I have that doubt. Okay.
hmm,
See, like you are using for loop. Okay. And after that, why? See, my question is, see, recursion is a type of for loop. Okay. Then why again we are using in the permutation for loop? Means, I got stuck in that.
sir, no, sir, because see, don't feel that wherever loop concept is required, wherever loop concept is required, we can't replace with the recursion. Point number one. Generally, so when we are going for loop, if you want to repeat any statement, then we can go for this loop, right?
Huh.
So some up to certain level of problems we can solve by using loop. But if the problem statement is very complex and if there is any pattern, then we are going for this recursion. This is point number one. Second point, inside recursion. Inside recursion, so we can't take a loop. We can't take a loop. Such a type of terminology is not there. Here, the situation demands. For example, if the given string is ABC, how many combinations we are getting? Six combinations, right?
Correct.
If I am taking ABCD, procedure is the same. We will get a 24 combinations. Am I right?
Hmm.
So if you take A, B, C, D, E, around 120 combinations you are going to get.
Hmm.
So how you are going to get those combinations? We have to take one character from here and
Hmm.
you need to remove that character from this and we have to add to the result. That
Hmm.
process we have to repeat. Since we have three characters are there, first we have to write a loop to run three times. Next time, we are removing on one character and we are moving that character to the result. So after that, what will happen? Your length of the string will become 2. Again, your length of the string will become 1. So the pattern is there. But first time you have to apply that pattern for 3 times. Second time you have to apply for 2 times. So third time you have to apply for 1 time. Whenever it comes to 0, it will stop. So for this also again don't go for recursion. Recursion inside recursion will leads to so some issues. That's why to overcome that here we are taking a loop because it is a repetition process, right?
Hmm.
Got it, sir?
Hmm.
So there is no universal rule that recursion problems inside the recursion we can't take a loop. Such a type of things are not there. Got it?
Hmm.
So
Okay.
another example I will give for you to understand. For
Hmm.
example, if I want to perform any
Hmm.
factorial calculation,
Hmm.
already we have seen we developed a code for that.
Correct.
Assume for every number, I need to do some three calculations. Again, inside the factorial, so is it possible to take the loop? Here the requirement is like that. Definitely we can take. Are you getting my point, sir?
Yeah, yeah.
So inside recursion, based on our requirement, we can take any number of statements and you can take a loop also, no problem at all. Got it?
Got it.
Right, sir.
Hmm.
And today's program, I mean, today's topic is very, very important. More attention must be required. What is the topic here is backtracking. Backtracking. Sir, very, very important topic. Please focus more. So I want to take introduction for this. Sir, what is mean by backtracking? I can say it is also a recursive. It is also a recursive method. It is also a recursive method. Here also we are going to use this recursion. But what is the purpose of this one is nothing but it is a process. It is a process of moving. It is a process of moving. Okay. Or it is a process of finding the solution. Finding the solution. So if proper result, if the proper result is not found, so we can backtrack. Backtrack means what? So coming out from that path, from that path and selecting a new path, selecting a new path. Yes, this type of scenario is there in the backtracking. Okay, but how to use this backtracking step by step I will explain. Okay, just to give me 1 minute, please wait. Yeah, so this is nothing but what we have about backtracking. So backtracking means what? It is nothing but a recursive method where we are going to get a proper solution. So that means what? We are keep on searching for the solution. Once if we are getting the solution, then okay. Suppose if there is no solution, what we have to do? We need to backtrack. Backtrack means what? Coming out from that path and searching for another new path. Sir, best example for this, if you take number locks. Okay, number locks, especially suppose if you have any box is there. So please listen this example, it is very very important. Suppose if you have a box is there. Okay, that box is locked with some pin number. Okay, that box is locked with some pin number, and how many digits that pin number has? 3 digits are there. Now my target is we have to unlock this. Okay, but I don't know what is a pin. I want to unlock this. How you can do? How many combinations we are going to get? First I will try with 0 0 0. Listen my words carefully. I didn't open the lock. Then what is the next combination? 0 0 1. What is the next combination? 0 0 2, and so on. I will take up to 0 0 9. Sir, the box is not opened. Then what is the next combination? Can anyone tell me? What is the next combination?
010.
Yes, good. That means, sir, you have to backtrack up to the beginning. Don't change the last bit. Try to change this bit so that what will happen? 0 1 0. Okay. Next 0 1 1. Next 0 1 2. So 0 1 3, and so on up to so 0 9 9 we will get. After that, what we have to do? Come backtracking. Then we have to take 1 0 0, then 1 0 1, then 1 0 2, so on 1 1 1, and so on 1 2 5. Okay, and so on 9 9 9. Like this, all possible combinations we have to check. Sir, we are keep on moving to find for the solution. If the solution is not found, we will move backtracking, we will move back step, and we will search for the solution. This is one way. Another way, another example, sir, more real time example. I think you faced these kind of scenarios, maybe in your lifetime. Sir, path finding. Suppose consider, so you are coming to my house. Okay, you are coming to my house, and I have given a very clear instruction that you have to start from so and so point, and there is a road is there. Sir, after coming to this, sir, there are multiple paths are there to come to my house. There are multiple paths are there to come to my house. So my house is located here. So this is nothing but the path like this. And unfortunately, this path never leads to my house. And this path, it is located like this. Something like this. Okay. Sir, you have to come to my house. Is it possible to move like this? No. If you are keep on moving, so I told that after 1 kilometer, you are going to get my house. But you came to 2 kilometers, but you didn't get. Then what will happen? So are you going to stop searching my house? No. Again, you will come back. Have you observed? This coming back is called as backtracking. So we are searching for a solution. If that solution is not found, you can come backward and you can choose alternative option. This is nothing but the best example. I think one more example I will provide so that you people will get clarity. Another example is, sir, do you know rat in mass? Maybe in your weekly newspapers and some puzzle books in that, so there will be a rat and you are going to put some mass on the last. Okay, or you are going to put some kind of food for the rat. Then what will happen? The rat has to move across all the walls, all the mass, and it has to eat that. Okay, sir, how it will be? Is it possible? So there will be multiple paths. Suppose if rat is moving in one direction, if he didn't get the food, then immediately that rat is going to come back, right? So that kind of a problems also comes under this backtracking. In the real time, there may be a chance of asking questions like this in the twisted manner. Okay, so rat in mass. Have you observed? You can see. Sir, here, if you want, I will take any one example where you will get a proper format. Yes, you can see this one. This is nothing but a best example for this. So, are you seeing here? Yes, a rat is available here. Okay, there are multiple paths are there. Okay, there are multiple paths are there. You have to travel like this. Okay, you have to travel like this and you need to go for that. Okay, but have you observed, if you enter into this box was completely closed, right? This box was completely closed. Maybe assume it is completely closed. Again, it has to come back and search for another path, search for another path. Do you know, this kind of technique is called as what? Backtracking. So in our example, okay, in our example, I'm going to take two applications to demonstrate this backtracking. What are those applications is, we are going to see how this sudoku puzzle is going to be solved, and even we are going to see there is one beautiful problem is there called n queens problem. How you can able to solve this n queens problem? These two examples we are going to see practically how we can work with the backtracking. There are multiple applications are there. Okay, so if you are clear with this, I will go for executable code. Please confirm clear.
It is time consuming, right?
Ah, yes, definitely. But there will be a solution, right? We don't have any alternative for that, right? So we will take some examples and I will explain. Just please wait for 2 minutes, sir. I will be back. Yeah, right. Sorry for the delay. So let us go. Sir, everyone understood the introduction to this backtracking? Please confirm.
Yes, sir. Sir, this all the five
Yes,
examples
sir.
we will be doing, right?
Sir.
This all the five examples we will be doing, right?
Yes, yes. Actually, I'm not going for all the examples. I will explain Sudoku puzzle and n queens where you will get complete clarity.
Means this rat in the maze and path finding and number locks also will come in there, right?
No, no, no. I'm going to explain only Sudoku puzzle and n queens. For this itself, every program will take 1.5 hour time. So
Okay.
later you can solve, but if you are getting any problem, I will explain. Don't worry,
Yes,
okay?
yes, sir. Yes.
Clear? Please confirm everyone.
Sir, for every problem that whatever you will solve, that will undecidable problem because it contain a because it will take exponential time. So is it any another method to solve that problem?
No, no, sir. There is no way. I'm explaining. What is your question? I'm not getting.
I'm asking that, sir, for every problem in a backtracking, it may
Hmm.
take, sir, exponential time or polynomial time.
Definitely, sir. We don't have any option, right? Other than this backtracking, you can't solve any problem. I mean, we don't have any methodology to solve these kind of issues.
And one more question, sir, is for every question there is a means backtrack will assure that for that problem there will be given a solution is means backtracking will assure you that it will give you a correct solution.
Yes, yes. Multiple combinations will be there. See, for example, if you take these number logs, how many possible combinations will be there? How many results you are going to get? Only one result, right? So
Yes.
you can see in my screen already I explained, when we have 1,000 possible combinations are there, only one combination will work, right?
Right, sir.
But if you take rat and mass, so source will be only one point, but destination multiple openings or multiple paths will be there, right? So in such cases, you are going to get multiple solutions. In that, which solution is best, that we can calculate later. But we will see all possible combinations. Okay,
Right, sir.
clear? Right. So, but before moving to this Sudoku problem or before moving to this n queens, just I want to give one example. Okay, how this backtracking is going to work. So backtracking with a list. So backtracking with a list. How you can able to work backtracking with a list? One simple example I am going to demonstrate where you will get clarity. Please focus on this and please try to identify the output of this program. I am taking one function called change is the function name. I'm passing one list as the index, I mean one list as the first argument. So index is the second argument, value is the third argument. Like I am taking three arguments. So initially, my list contains the values like 0, comma 0, comma 0, comma 0, comma 0. Total, how many elements are there? 5 elements. If you print the list, what output we will get? 0, comma 0, comma 0, 0, comma 0. Like this, we are going to get 5 elements. And I am going to call change function where I am going to give L comma 0 comma 1. So what I am going to do is, whenever we are calling change function, so initially we know what are the elements available in the list. So in my list, what values are there? So we have 0th, first element is 0, second element is 0, third element is 0, fourth element is 0, fifth element is 0. Like this we have. So like this we have. And what is the index value that we have given? The index value which we have given is 0. And what about the value which we have given? The value will become 1. Okay. Means what? In the index 0, I want to take this value. Sir, in the index 0, already 0 is there. I want to change this value to 1. So this is better. I will highlight in another color. 0th index, first index, second index, third index, fourth index. Like this we have. So next possibility is, I want to change this second value also. For that we have to write a function. Sir, observe carefully. Can I use recursion here? Yes. L of whatever index that you have passed, in that I am going to store a value. Okay, then I will call change function by passing the same list and index plus 1, and I am going to take value plus 1. Now see what will happen here. Sir, here L value is there. This is my list. So in 0th location, I updated the value 1. Next, again I am calling recursively where same list index in the place of index, what I am giving index plus 1. That means your index will become 1. What about value? Value plus 1. Sir, this value will become 2. Okay. So in first location, update this value. Okay. So next step, again it is going to call increment the index, increment the value. In second location, I am updating 3. And here 3, here 4. So here just increment the value with 4. And here 4 and here 5. So increment this value with the 5. Like this I am taking. Okay. So this is nothing but what we have. But it is a never ending process, right? It will keep on working. But how you can able to stop? Can we write a base condition? Where we can write a base condition? Based on the index, we can write base condition. Sir, what is that base condition? Here, see, I am going to write in the recursion. Here the base condition is if the value of index is double equal to length of the list, then immediately I'm going to return that result. That's all. Means what? I will stop this backtracking whenever the index value is reached to length of the list. Whenever the index value is reached to length of the list, I'm going to stop. This is nothing but the concept what we have. Okay. Sir, everyone please confirm, is this concept up to this whatever we covered? Is it clear?
Yes, sir.
Yes.
Clear?
Yes, sir.
Please confirm everyone.
Yes, sir.
Right. Right. So the next one, what we have, sir, I'm going to do backtracking here. And if you observe internally, definitely since it is a recursion, it is going to maintain one stack. It is going to maintain one stack. So in this stack, every method call will be registered, right? At the first time, what is the index value? So at the first time index is 0 and the value is nothing but 1. Second time index is 1, value is 2. And the third time index is 2, value is 3. Fourth time index is 3, value is 4. And here index is equal to 4, value is equal to 5. Like this it is keep on adding, but whenever the value of I became 5, immediately it is a stop. Means what? Can I say like this process is continued, right? Backtracking means what? From here it will come back. I will explain how it is going to work. Okay. Sir, is this diagram is clear for everyone? Please confirm. Is the diagram is clear for everyone?
Yes, sir.
No. Sir,
Yes, sir.
yeah. So here nothing is there, just only one line we have to take. After this recursive call, that means in the non-tail recursion, if you are taking L of index is equal to, okay, L of index is equal to L of index minus 2. Like this I am taking. This step is called as backtracking, and this step is called as recursion. Like that we have. And this step is called as what? Recursion. And this step is called as what? Backtracking. Like this we have. Okay. So now let us see what will happen. I am explaining in another color. Let us see what will happen. Here the condition fails. So this entry is there in the stack. So we have to delete this entry. How you can delete? We are taking L of what is the index value at this point? Index value is 4. What is its value, sir? Already we have 5. 5 minus 2. That means what? Its value is 3. In L of 4, I am updating with 3. So this entry will be deleted from the stack. Again backtrack. Now what is the index value? Again it will execute, right? Because how many times this line executed, those many times this line will execute. So I'm taking L of 3 is equal to. So what is its value? Previous value is 4. 4 minus 2 means it will become 2. So that value will be updated with 2. Now again this entry will be deleted from the stack. It will come back. So L of 2 is equal to, already we have 3. 3 minus 2 means 1. You will get 1. So L of, if you take 2 minus 1, 1. So here you can see what is a L of 1 value. This entry got deleted. It is nothing but a 2. 2 minus 1 means you will get 1. And if you take last one, so L of 0 will become, so what is the previous value, sir? 1, right? So 1 minus 2. Okay, 1 minus 2, which is nothing but minus 1. So these entries also deleted. So all the stack elements got completed and now it will stop. Now I am printing the list, sir. What output I am expecting? You can see in the list what is happening. So I am expecting -1. Okay, -1. I think here 2 minus 2, you will get 0, sir, right? 0 you will get. So -1, then 0, then +1, then 2, then 3. Like this we are going to get. Sir, is the technical concept, what is happening? Is it clear? Got it? How the list is changing? Is it clear? Please confirm.
Sir, kindly explain once again.
Sir, that sixth line which you have written,
Hmm.
in that, what is the no. See, actually, if you will print the list without the sixth line, okay,
Hmm.
it will be like 0, 1, 2, 3, 4, right?
1, 2, 3, 4, 5.
1, 2, 3, 4, 5. Sorry, my
Hmm.
pardon. 1, 2,
Hmm.
3, 4, 5.
Yes.
So my question is, why you did that index -2? What is the necessity of that?
Actually, this is not a application, sir. Just I am explaining how backtracking is going to work. As of now, if you see, the
Mhm.
output of the program is 1, 2, 3, 4, 5.
Uh-huh.
That means what, starting from the 0th location to keep on, we are updating.
Correct.
So after this line, this is the recursive line, right?
Correct.
So after this, if you are taking any statement, this statement never executes actually when recursion is working, because you can see
Yes, sure,
first
sure.
time
Yes.
change function will call for 0, 1.
Mhm.
Next change function will call from 1, 2.
Mm.
Next 2, 3. So
Mm.
next 3, 4. Next 4, 5. That's all. Whenever index value will become 5, it will stop.
Correct.
So like from here, it will go here. Again from here, it will go here. This sixth line never executes.
Correct.
But it is also a part of code, right?
It will be executed after all the things is there in the stack.
Yes, that's what I'm explaining. When I'm coming back, what is the proof that I'm coming back? For that, I'm doing a small modification in the list.
Oh, okay, okay.
What is that modification? I'm
Mhm.
reducing that element value by 2 units.
You are
Okay,
value.
got
Yes,
it?
yes. Got it, got it. Yes, 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 yes. Got it.
Sir, everyone please confirm who asked the doubt previously. Is it clear, sir, now? Sir, everyone please respond. Is the
Sir,
concept is
clear,
clear?
sir.
Yes, please confirm so that we can go for the application.
Sir, I have a doubt. Sir, in the stack, no. It is fast in, fast out, or last in, fast out means fast, it will be going from down, means suppose, or it will be from the up.
No, sir. While inserting, it will go from the bottom to top.
Bottom to top.
So now when it is coming for backtracking, when you are coming from backtracking, what will happen? It will come from last to first. Okay.
Correct.
Got it?
Got it.
Clear, sir? Can I go for executable code for this?
Yes, sir.
Right. Right. This is nothing but what is happening here. Okay. Now, just I want to show you. So by removing these comments, if I execute, what will happen? Initially, it is 0, 0, 0, 0, 0, but now it is nothing but what? Minus 1, 0, 1, 2, 3. Sir, whatever output we have drawn, same output came. Sir, I want to show you that 1, 2, 3, 4 also, how I can able to display. Very simple. Inside the base condition, whenever the base condition satisfied, I will print that list also, so that what will happen at the very beginning, these are the values. Whenever base condition is satisfied, that means what? All the values we updated, right? What are the updations that we have done? So 1, 2, 3, 4, 5 will be there, right? Those values also will come. If you want, you can see these are the initial values, and 1, 2, 3, 4, 5 came, and minus 1, 0, 1, 2, 3 came. Like that we have. Sir, this is nothing but an example. What is the proof that? What is the proof that how the backtracking is working? Sir, everyone feeling comfortable up to this, whatever I covered? Please confirm.
Yes, sir.
Clear up to this? Can I go for the application?
Yes, sir.
Right. So let us see the real-time application. Sir, please confirm everyone.
Yes, sir.
Right. Now we are going to see how this n queens problem is going to work. First, I will demonstrate what is mean by n queens problem. Later, I will go for the solution. Of course, it is a big problem, sir. So we have to understand the problem statement. Problem statement will become very difficult for us. So I mean, somewhat tricky. Please focus on this. In the n queens problem, okay, so I have 8 by 8 in the n queens problem. 8 by 8 chessboard is there. So it is called as n by n. N queens means n rows, n columns will be there. But it is very difficult for us to explain 8 by 8, right? That's why what I am going to do is I will take a 4 by 4 chessboard for better understanding purpose. This is nothing but a zeroth row. This is nothing but a first row. This is nothing but a second row. And this is nothing but third row and fourth row. Like that we have, so 4 by 4 chessboard is there here. Like that we have. So assume in this 4 by 4 chessboard, my requirement is this is 0th column, this is the first column, this is the second column, and the third column. So this is 0th row, first row, second row, and third row we have. Now my requirement is, sir, I have to place one queen. In this, we have queen related terminology will be there in the chessboard. Queen means some people may use the word called minister. What is the role of this minister means in the chessboard, that minister can move in any direction. Suppose if you take a minister here, it can move in this direction. This minister can move in this direction, or in the straight line path, or in the diagonal path also it can able to move. Okay, so maybe it is in the first row, that's why you are getting confusion. Suppose if you take a queen here, then this is one way, this is another way, this is another way, this is another way, and this is one 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 way. Total how many ways are there to run? Around we have 6 plus 3 plus 3, 6, 7, 8 possible ways are there. In 8 directions it can move. One is a left, right, top, bottom. So diagonals, in the 4 possible diagonals it is going to move. Now your task is you have to place the queens in the chessboard. Like for, here, what is the chessboard size? 4 by 4. So we have 4 queens are there. You have to place all these queens in the chessboard. Like In every row, one queen we have to place. Here I placed one queen. 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 No problem. But there is some rule. What is that rule? Is no two queens should collide with each other. Means what? Sir, this queen can move in this direction. Is there collision or not? Yes. That should not happen. Like that, you have to arrange. This is nothing but our task, sir. Please confirm, is the problem statement, is it clear for everyone?
Yes, sir.
Yes, please respond.
Sir, in the pathway,
Hmm.
anywhere any first pin shouldn't be colliding with the.
No, not only first queen. You can take any queen. Here, the size of the chessboard is 4 by 4, right, sir?
Hmm.
We have to take how many queens? 4 queens we have to take.
Okay.
In every row, we need to place one queen.
Okay.
Such that no two queens should collide with each other.
In every
If you
row.
take any queen, it should not collide with other queen. That is a problem. That is the task. Got
Okay.
it?
Okay. Okay. Means the queen can move any direction. The queen can move, right?
Yes.
But our condition is for
In
every
that
row.
path, when it is moving in that path, it should not collide with another queen. That means in that path, there should not be any other queen. That is the task.
Okay.
I
Okay.
will explain the solution. You will get clarity.
Yeah. Yes. Yes.
Sir, is the problem statement is clear for everyone? Can you please confirm one more time? Right. Sir, I will go with another paint here. So now I am trying to give the solution for this. Please observe carefully. So here, yeah, guys, please focus. So first, in the first row, I am taking a queen. Can I take a queen here? Because there is no other queens, there won't be any collision. You can see in these directions, there is no queen. Of course, it can't move towards left, it can't move towards up, and it can't move in the diagonal because this is the starting point. Yes, it is valid. So already in the first place, one queen is there. Sir, can I take a second queen here? Everyone please confirm. Can I take here?
No, sir.
Yes, good. Why? Because the collision will happen. Am I right?
Yes, sir.
Can I take here?
No.
No, sir.
No.
Can I take here?
Yes.
Yes.
Yes, sir.
Right. First queen is there in its position. Second queen is also there in its position. Now I am taking third queen. Can I take third queen in this place?
No.
No, sir.
Can I take here?
No.
No, sir.
No.
Can I take here?
No.
No.
Can I take here?
No, sir.
Now, can you please confirm? There is no place for the third queen. Am I right?
Correct.
Yes.
Yes, sir.
We didn't got the solution. One step backward. Where we have placed the second queen actually in which position? Second position, right?
Yes.
Can I move that position to the third position and we can try? Am I right?
Yes.
Now I am taking third position. Now, can I place second queen here, third queen here?
No.
No.
Sir.
Can I
No, sir.
place here?
Yes. Yes.
Got it?
Yes, sir.
So this is nothing but like this we have to verify. Sir, up to this everyone, please confirm. Is it clear?
Clear. Yes.
Yes, sir.
Arvind Saho sir, now you got clarity.
Yes. Yes. I got it.
Problem seems to be very interesting, right?
Yes. Yes.
We have to see how to develop the solution for this. Then you will get actual.
Yes, I got it. Yeah.
Right. Now, can I take third queen here?
No,
No.
sir.
No.
Can I take here?
No.
No,
No.
sir.
Can I take here?
No.
No, sir.
Can I take here?
No.
So
Yes.
that means
Yes.
what?
Yes, sir.
No, no,
No.
you can
No.
see.
No. We can't.
No. Yes, sir.
No, sir.
Okay.
No, sir.
Right. So there is a problem. And that's why what I am doing is I am shifting the third queen to this position. Can I take?
No. No. No.
No,
Can I
sir.
take here?
No.
So can I say the first queen where we place itself is the wrong place,
Ah.
right?
Yes.
Now
Yes, sir.
can I move that queen to the second position here?
Yes.
Now observe, I am explaining directly. Here we can't place, here we can't place, here we can't place, but we can place here. Is it clear?
Yes.
Clear.
Third queen, can I place here?
Yes.
Yes, sir.
Fourth queen, can I place here?
Mhm.
No. Can I place here?
Mhm.
No.
Can I place here?
Yes.
Can I say is it a
Yes, sir.
solution?
Yes.
Got it?
Mhm.
Now observe carefully. We have another possibilities also there. Why? Because you can see here we have taken. Can I take queen here?
No, sir.
No, sir.
Okay.
No. No.
So can I take this third queen here?
No.
No, sir.
Can I take third queen here?
No.
No, sir.
Can I take here?
No.
So now we have seen by placing the first queen in second position, what is the result? Can I take here also, right?
Yes.
Now see the possible combination. Here I am taking, here we can't take, here we can't take, here we can't take, but here we can take. So here we can't take, here we can take. Is it another solution?
Yes, sir.
Yes,
So
sir. Yes.
we can search in another way also. Like here we place it, right? Now I am taking here, not possible. Here, not possible. Now this all combinations got completed. Here we can't take, here we can't take. So here we can't take. Now I am moving here. So here we can take, here we can't take, here we can't take, here we can take. So here we can't take, here we can't take, here we can't take, here we can't take. And this queen here we can't take. And can I take a queen here? Yes. Here we can't take, here we can't take, here we can't take, here we can't take. And here we can't take, here we can't take. So these are the only two solutions. First solution, second solution. Sir, everyone please confirm, is the problem statement and how physically it is represented. Is it clear?
Yes, sir.
Yes, sir.
Okay. Now we have to convert this. Now we have to convert this into executable code, and let us see how that code is going to work. We have to convert this into executable code and we have to see how it is going to work. Sir, very simple. I am taking some three functions here. One is nothing but sir, safe. This is one function I have. Later I will write code for that. Then I'm going to take the main problem like n queens. I will write a code later. Then I'm going to write one more function called print board. Board means chessboard. So I want to print the board. That's all. Only three functions I'm going to take. So initially, so I'm taking a 4x4 chessboard. N is equal to 4. Now I'm calling n queens problem. Okay. Or before that, we have to create a board, right? So board is equal to, I can say it is a list, or better easy understanding purpose, I am taking L. List is equal to, it is a nested list. I am taking X matrix style. X for each I value in the range of n. Again, for each I value in the range of n. Like this I am taking. So here, L is chessboard. L is chessboard. Means what? Observe carefully. That point alone I am expressing. Sir, n is equal to 4. What is this one? It is going to create X. for each I value in the range of n. What is the n value for? 0th time, first time, second time, third time. Like this, how many times? N times. Means what? Like this I am going to get. Initially, empty values we can't represent, right? That's why I'm using the word called x. It is easy for us to represent. So x indicates empty place. Empty place. Q indicates there is a queen. Queen. So now you have to replace this x with q, sir. That is nothing but our task. Okay. But initially we can call so print board where it is taking a list. Where it is taking a list, we have to print each and every element present in that list. Anyway, I will explain that process. Can you please tell me, is these two lines, 11th line and 12th line, is it clear?
Yes.
Is it clear? 11th line and 12th line. Is it clear? Please confirm.
Yes, sir.
Right. So next one, I'm implementing this print board. I'm implementing this print board. In the print board, so I'm taking a list. Okay, I'm taking a list like this. We have to print each and every element in this list. How to print? Sir, print off. I'm taking just some chessboard, something like this. I'm printing a message. So after this, okay, so after this I'm taking for each I value in the range of length of L, I'm taking length of the list. For each j value in the range of length of the list, I'm taking like this. And here I want to print L of ij comma end is equal to empty, like this I'm taking. And I will print one empty line, and after this just I'm going to so print these hyphens. Sir, what I am doing here? I am printing a matrix. For each I value in the length of L, how many number of elements are there? Sir, 4. For each j value in the length of L, that is nothing but 4. Sir, can I say 4 by 4 matrix? So L of 0, 0, that means first x, then second x, like that it is going to print. Let me execute up to this so that you can see. Sir, this is nothing but the chessboard what we have. Suppose if you want to implement 8 by 8, you have to replace n is equal to 8. Now you can see 8 by 8 chessboard we got. So now in this first row, we have to take only one queen. In the second row, we have to take only one queen. Like in every row, one queen we have to take, so that no two queens should collide with each other. Like that, we have to write manual code. Sir, please confirm if this skeleton of this program is clear. I will start implementing this n queens and safe. Please confirm.
Yes.
Yes, sir.
Yes, sir.
Right. Right. Now we will see how we are going to implement these n queens first. So we have to implement which one? N queens. First, I will take n queens method. Please focus on this, sir. So this n queens is going to take some parameters. Which parameters it is going to take? It will take one list, and I am going to represent a row. So we want to focus on the column. Why? Because we need to take the queen only in the row, right? We have to take the queen only in the row. So that's why column is not that much important as of now. We have to take only in the row. That's why I will focus on only row. That's why I'm passing list comma row. Okay. Sir, for each j value, in the range of length of L, because we have to take the columns. So if you want, just have a look once. Parallelly, I will take one example. This is nothing but my chessboard what I have. So I am explaining that problem, how it is working. I mean n queens function. Sir, please look into this. What about the dimensions? I mean, what about the values for each and every cell? 0, 1, 2, 3. So 0, 1, 2, 3. So this one indicates 0, comma 0. This one indicates 0, comma 1, and so on. For each j value in the range of length of list. Sir, what is the length of list? Actually, 4 elements are there. So what will be your j value? J is equal to 0. Next time your j is equal to 1. Next time j is equal to 2. Next time j is equal to 3. Sir, what is happening? After this, what we have to do? Sir, inside this loop, I am going to write if is safe, or if safe of, I will provide the list value, comma row value, comma j value. So first time, what is the value of j? It is nothing but 0. So row value is what? So row value is 0 and j values are 0, comma 1, comma 2, comma 3. So 0, comma 0 I am taking. I am passing. So list 0, comma 0. Is it possible to place a queen here? Who will decide? Sir, is a safe function is going to decide. If it is returning true, we can place. If it is returning false, we can't place. Suppose if it is true, that means what? We can able to take a queen in that location. Sir, how you can able to take? That we have to write code. One second. Now, let us see. Suppose assume it is returning. If it is returning true, what we have to do? Can I take L of row and then J is equal to queen? Yes. Sir, now listen, I am taking one example. Sir, first time R is equal to 0. Okay. So 0, comma 0, comma 1, comma 2, comma 3. This is the values. Okay. Row value is nothing but 0. Column values are nothing but what? 0, 1, 2, 3. Sir, for this, my is safe function is going to return true. That means we can take a queen in which position? 0, comma 0. Then after that, what I am going to do? We have to go to the next row, because in the first row, we placed the queen, right? How to go to the next row? Can I call the same n queens problem by taking the list row plus 1? Can I say, is it a recursion or not? Yes. Sir, now what will happen? The same function, it is going to call for 0. No, row plus 1. Row value will become 1. For this, again, it is going to call. Now it will check 0, comma 1, comma 2, comma 3. Now, is it possible to take at 0, comma 1? No, because isSafe function is going to return false. Sir, can I take here? No, isSafe function is going to return false. Can I take here? Yes, isSafe function is going to return. That means this is not executed. This is not executed. This is executed. Okay. Now, after this, what will happen? Again, it is going to call L row plus 1. Now it is going to call for second row 0, comma 1, comma 2, comma 3. Now what is happening? So in 2, comma 0, is it possible to take isSafe function? So 2, comma 0, it will return false. 2, comma 1, it will return false. 2, comma 2, it will return false. 2, comma 3, it will return false. That means there is no possibility. Everyone please confirm these 3 steps in the white color, whatever I have drawn. Is it clear? Sir, please confirm everyone. Is the concept is clear? Good. Sir, please confirm so that I can go for the next. Right, sir. Now, what I am going to do is, sir, here, in every case, it is returning false. That means what? We have to go back. Already we tried with 0, comma 2. Sir, 1, comma 2. It is not working. Can you please shift this place to the next one? But if I want to change this queen, we have to reset this value to x, right? So how to do that? That is called as backtracking. Sir, here I am taking L of in that specified row and in that specified column. Can you please take X? That means we are resetting that value and we will go for the next possible way. This step is called as backtrack. That's all, sir. So n queens problem is nothing but this one only. But when it will stop, when it is going to stop, can I say if the value of row is reached to the length of the list, row 0, row 1, row 2, row 3, row 4, whenever row value will become 4, can I stop this? Yes. So if row is equal to length of the list, just simply I am going to print the result, print board of L, and then I will stop the process. This is nothing but what we have n queens function. Sir, if you understand these, then we need to demonstrate how safe function is going to work. Can you please confirm up to this whatever I covered? Is it clear?
Yes, sir.
Sir, I need response from everyone. Please confirm, is it clear? Right. So anyway, is a safe function is there that we will discuss tomorrow in detail. But I request everyone to please watch this video one more time before coming to the next class. So tomorrow directly we will go with safe function, which is very, very important. And tomorrow I will complete this safe function. And even we are going to see the Sudoku problem also. And even tomorrow the timings is also same. You have to join at 6:30. 6:30 to 8 we will complete this backtrack. Okay. And after Diwali, we will speed up the syllabus by starting with actual data structures like sorting algorithms. Okay. So I request everyone, I will instruct admin team to upload this video immediately. I request everyone to please refer this video minimum 2 times and please understand the flow of control. If possible, try to take a paper and pen and draw these things. These function, if you are clear with these, tomorrow I will explain is safe. Okay. But as of now, you know, right, how is safe function is going to work. So if there is any possibility, it will return true. Then we have to do these steps. If it is returning false, we can't able to take. Like that, just imagine and code it. Okay. Sir, please confirm clear up to this.
Yes, sir.
Right, friends. So thank you. We will meet for the continuation tomorrow. Tomorrow I will explain that E is a safe function. Thank you guys. See you tomorrow.